Okay, let's look at some more concepts on sets. The first one we want to talk about today is the null or empty set. It is possible that a set will have no elements. When that happens, it is called an empty set or a null set, and it is denoted by this symbol, the curly brackets with nothing in between it, or the zero with a slash. So a null set can be compared to an empty bag with nothing inside it. A good example is the one shown here. We have set A being equal to just the curly brackets, nothing in between it. So that qualifies as an empty set. Another one, set B, is defined by B such that B is a set of prime numbers that are even and greater than 2. Think about that for a second. There is no prime number beside 2 that is an even number. And since you are eliminating 2, you will not find any other fitting element as well. And so B is also an empty set denoted by our good old symbol, this or that. Let's look at another terminology, subsets. To explain that concept, look at the set P, which is defined by X such that X is an odd number less than 16. And then set Q, which is also defined by A such that A is a prime number less than 8. We can see the elements of set P and then set Q as below. Now take a look. The element 3, 5, 7 can be found in set Q. In fact, all of these elements are what we have here. So because every single element in set Q can be found in set P, then we can see set Q is a subset of set P. Mathematically, this is how we represent that statement. Q is a subset of P. Mind you, Q has to come first, and then this symbol, you can picture it as a less than sign before the set P to show that this is the parent to this, or Q is the child to P. Another example, we have Y being defined as days of the week. So Y will have the elements Monday, Tuesday, Wednesday, Thursday, Friday, and then Saturday and Sunday. And then set Z being defined as weekends or weekend days. Then Z will have Saturday and Sunday as its elements. You can see that every element here can be found here. So we can see Z is also a subset of Y represented mathematically this way. Alright, now have a go at this example and let's see. Say you have set P, which is defined as the even numbers -4, 2, 0, 4, 6, 8, 10, and then 12. Which of the following will be a subset of set P? Is it A, B, C, or D? Have a go at it and then we'll all talk about it later. Clearly, you can see that every element here cannot be found here. Not all the elements here can be found here. So 5 and then 7 does not exist in set P. So we can't say that A is a subset of Q. The same way, when we come here, we can do comparison. We see that 4 is there, 0 is there, 6 is there, and then 10 is there. So B is a potential answer. But let's look at other options and see whether we find another one. When we come to set C, we see that it has 1 here which does not exist in set P. So this does not qualify as a subset of P. Similar thing happens with set D, which has 1 and then does not exist in set P. So we can see that only B is a subset of P. And so B qualifies as the answer to the question. Opposite of a subset is not a subset. An example like this can help us understand clearly. If set A has elements 2, 4, 6, 8, 10, and 12, and then set B has 2, 4, 5, and 12, even though 3 of them exist in set A, because there is the presence of 5 which does not belong here, B does not qualify to be a subset of A. And so you see B is not a subset of A. And that statement mathematically is represented as B, not a subset of A. Give a try to this question. Let's see. Which of the following is not a subset of set W? Is it A, B, C, or D? Take a pause and go through it. Alright. When we look at the answer options, you can see the first of all, we can see W is a set of multiples of 5. So everything here is a multiple of 5. Then, when you look at the answer option A, everything here can be found there. So it is a subset. The same thing happens with B. Everything here is a subset. C, everything is a subset. But D, we have 24. And 24 cannot be found here. Because of that, D is the answer to the question. Because D is not a subset of set W.